In this section, we take another look at vectors, this time from an algebraic point of view. So I've written here, let's let u be the vector 3i plus 4j, where I and j are unit vectors, one in the positive x direction and j in the positive y direction. And v is 2i minus 3j, and then let's find, 1, the graph of u. Well, to graph the vector u, I draw an arrow from the origin out to the point 3, 4. So the vector is going to go from the origin out to the point 3, 4. So x equal 3, y equal 1, 2, 3, 4. And so that is going to be this vector right here. So there's a picture of vector u. Next, I want to find the magnitude of u, and so that's really the length of this vector right here. And so, by definition, that comes out to be the square root of 3 squared plus 4 squared. So the square root of the I component plus the square of the I component plus the square of the j component. Square root of 9 plus 16, which is 25, and that comes out to be 5. So the magnitude of vector u is 5. Now the next thing I want to do is I want to add vectors u and v, and I add them just like I would regular polynomials. I add similar terms. I add the I components and I add the j components. So u plus v is going to be 3i plus 4j plus 2i minus 3j. So it will look like that. If I was using the commutative and associative properties, I could take away the parentheses, change the grouping. In any case, I'm going to have 3i plus 2i, which is going to be 5i. And then I'm going to have 4j plus negative 3j, which is going to be 1j. So plus j. So the sum of the vectors u and v is 3i plus 4j plus 2i minus 3j, comes out to be 5i plus j. Now let's take a look real quick over here on the graph and see if we can see where the sum of those two vectors lies on this graph. So I want to go back here and graph vector v to start with. So I go to graph vector v. That's going to be the vector that goes from the origin out to the point 2, negative 3. So x equal 2, y equal negative 1, 2, 3. So that's this vector right here. Now, the thing about these vectors is we're free to move these vectors around wherever we want. So I'm going to move this vector v from here up to here. And so it's going to look like this. That's vector v. And when I put the tail of v onto the tip of u, then the vector I get when I go from the tail of u to the tip of v is the sum of the vectors u and v. And so this vector right here is the vector u plus v. So that's that black vector that I've written right there. And look, it goes from the origin out to the point x equal 5, y equal 1. And sure enough, that is the vector 5i plus j. So you can see algebraically right here, I get it this way by just adding like I would polynomials. And up here, when I do it geometrically, by constructing this little diagram, I get the exact same vector. So my geometric rules and my algebraic rules are consistent with each other.